there. Let's work example 2 in this lesson. It is widely accepted that approximately 13% of Americans are left-handed. What is the probability that in a random sample of 200 Americans you find more than 15% are left-handed? So there's quite a lot to sort of sift through here, and I like to identify all the key parts of this problem. So as I read, I see this fact that 13% of Americans are left-handed. Keep on reading. It says, what is the probability in a sample of 200? So there, random sample of 200. It's another fact. And finally, keep reading. What's the probability that more than 15% are left-handed? So as I go and try to make sense of this, my first thing I get to is 0.13. That's the equivalent for 13%. I'm going to label that P. That is my population proportion. 13% of Americans is sort of a global statement, P. I'll take that as that. And then I will determine Q by finding 1 minus P. It's the complement. So Q is equal to 1 minus 0.13. Q is equal to 0.87. So in this problem, a success we can see is being left-handed, and that's why I labeled P equals 0.13. The probability of not being left-handed or being right-handed is 0.87 or 87% of Americans. The next thing I'll sort out is that N here, our sample size is 200. And the last piece of information I get is that more than 15%. Now this 0.15 is attached to the sample, a smaller group, not all Americans, but a smaller group of 200 Americans. So this is going to be our sample proportion P hat. So I have an idea of how I might want to solve this by using the normal distribution. Before I do, I need to check that the assumptions and conditions are in order. So the first thing is that we have a random sample. This is indeed a random sample of 200 Americans. The next thing I need to be certain of is that the conditions for the binomial are met. Here they are. You could pause this video and read through these, but they are in fact true. And finally, that we have at least 10 successes and 10 failures. So if I multiply n times p and n times q, I want those products to be at least 10. So we can see here 26 is indeed greater than or equal to 10, as is 174. So since these are met, I can now proceed and solve this probability question with the normal model. So in this situation, it is a sampling distribution of proportions. P, our population proportion, goes in the middle of the distribution where the mean is. So I placed it there. After I find the mean of any distribution, I like to also find the standard deviation. If you recall, the standard deviation for a sampling distribution for proportions is equal to P times Q over N, all of that under the square root. I've inserted P, Q, and N into that formula, and if I get out my scientific calculator, I find that the standard deviation is equal to 0.024. I have 3 equally spaced tick marks here to the right, and I want to label them by stepping a standard deviation out each time. So I'm going to add 0.024 every time I move to the right. So that would give me 0.154, 0.178, add another 0.024, I end up at 0.202. So this is the model. I could label the left side, but I know that my p hat is 0.15, so I don't need to label the number line to the left. So it's just enough for me to label it to the right. I want to insert and see where the sample proportion they're interested in, 15%, falls. So it falls right there to the left of 0.154. Label it there. And the question asked more than 15%. So I'm going to shade to the right. So this again is a sketch of the situation. It's very helpful to do this because we're about to go to software and have it help us find the area of this sort of rainbow shaded area in my normal curve. And it's nice to go with a game plan. So let's keep in mind 0.13 is the mean, 0.024 is the standard deviation, and stack crunch. Calculators, normal. Have it here yet again. We're using this model for many purposes in this course. So here it is. So what I'm going to get here as the mean, I'm going to put 0.13. The standard deviation, if you recall, was 0.024. Now that's a calculation you will have to do by hand. It's not directly given in the problem. You have to calculate that, as you saw. And we did a more than, so we'll go greater than here, or greater than or equal to, and we'll have 0.15. Hit compute, we'll get our solution. I do want to put the tick marks in so you can sort of see this is the same problem I drew on the previous PowerPoint slide. So this is indeed giving me the probability of more than 15% being left-handed. You can see I highlighted it there in blue, no need to round. So 0.202 is that probability. So again, we have that. Lovely, it's an answer, it's a number you could key in as a solution to a problem, but what does it mean? What does it mean, 0.202? So it means there is a 20.2% chance that in a sample of 200 Americans, more than 15% of them would be left-handed.